Hey guys, this is the last topic in your Laplace transform chapter. So, this is another method to find the Laplace inverse. So, sometimes the question will specify if you need to use partial fractions or convolution theorem. So, we need to know both the methods. So, if you have a convolution of two functions ft and gt, then Laplace inverse of, if you have Laplace inverse of fs as ft and Laplace inverse of a function gs as gt, then Laplace inverse of fs multiplied by gs is ft convolution gt. This is given by integral 0 to t f of u multiplied by g of t minus u du. This is how you will find the answer. So I'm going to take a very basic example again. For example, you need to find Laplace inverse of 1 upon s plus 2 into s minus 1. Now you can do this very easily with partial fractions, but what if the question says by convolution? So here what you do, you take one function as fs, so that will be 1 upon s plus 2, and you take the second function as gs, which will be 1 upon s minus 1. And now you find Laplace inverse of fs, that is Laplace inverse of s plus 2. This is what? E raised to minus 2t. This becomes your ft. Similarly, find Laplace inverse of 1 upon s minus 1. This becomes e raised to t, and this becomes your gt. So now Laplace inverse of fs multiplied by gs will be given to you by 0 to t fu multiplied by gt minus u du. Remember guys, this is du, not dt. So you can write 0 to t e raised to minus 2u multiplied by e raised to t minus u du. Now since your variable is u, you can take the t term outside. So you can write this as e raised to t 0 to t e raised to minus 3u du. So this will become e raised to t e raised to minus 3u divided by minus 3, 0 to t. So this will become, let's take out e raised to t divided by minus 3. So this will become e raised to minus 3t minus 1. So your final answer is e raised to t multiplied by 1 minus e raised to minus 3t divided by 3. So this is a very basic example. Let's take something a little more difficult. So for example, you have Laplace inverse of s into s plus 1 divided by s square plus 1 multiplied by s square plus 2s plus 2. So now we need to check how we should split these two terms. So first of all, I can see that I can write this as s plus 1 divided by s square plus 1 into s plus 1 whole square plus 1. So clearly we should club these two terms and these two terms. So let's take our first fs as s plus 1 divided by s plus 1 whole square plus 1. So Laplace inverse of fs becomes cos t multiplied by e raised to minus t. Shifting theorem, guys. Now your second term will be gs, which is s divided by s square plus 1. So this is your ft. Now Laplace inverse of gs will be directly cos t. Remember guys, when you are doing convolution, your gs should be the simpler term, because over here you need to write g of t minus u. So it will help if this is the more simpler term. So I have taken this one as the more complicated one and this one as the simpler one. Now your answer will be Laplace inverse of s into s plus 1 divided by s square plus 1 into s square plus 2s plus 2. This will be 0 to t e raised to minus u cos u multiplied by cos of t minus u du. Now guys, I want you to try this. You will need to use cos A cos B formula, and then you will need to separate the terms. So try this. If you have any doubts, leave them in the comment section and I will solve it in the next video if you guys request it. If you have any other doubts in this or in the notes, again leave them in the comment section. I'll make sure I answer. Thank you.